Okay, let's get started. So we're doing maps all week. I'm really excited about it. I increasingly use maps on almost every project. I feel like I've got like a dozen papers or community projects. Every single one of them involves some sort of mapping or spatial analysis and mapping, if not just to map the results. And mapping in R is awesome. It's really easy relative to doing that work, especially repetitively in something like ArcGIS or QGIS or another GIS. So yeah, so if somebody has any questions, we're going to do a survey today of what maps are under the hood, what that data looks like under the hood, then do some coding in R, and you can follow along with today's zip file has an R script as well as a R data file that has like 4 or 5 different files, so you don't have to rerun your burst analysis. It's just got the county summaries that we ran that have like prevalence by county, so we'll merge that into a map and make some maps of that. And yeah, and you could, if you want, download and install QGIS while we're talking. It's free, it's open source, it's like R in that way, and it's great. I'll show you a couple of things in QGIS. This isn't a QGIS class, but we'll do a little bit of QGIS today just to show you how easy it is to work this particular workflow. It's sort of like the Excel or the table workflow to Excel to do the cleanup in Excel is very similar to QGIS. You know, we'll do rough tables in R, then clean them up in Excel. And in this case, we'll do some rough maps in R just to explore, and then move to QGIS for final layouts for publication and stuff like that. You could do it in R, it's just that's a little more work. Okay, so again, today we're going to do basic map concepts, so like the structure of a shapefile and how that matters, and then some basic spatial code. So it's like merging in data to a map, making a new map, but not really doing much spatial analysis. So the distance between things or buffers around things. Again, R makes that stuff crazy easy to do. So that really like puts in your toolbox if you don't have it already, to be able to ask questions and use that as covariates in a model, for instance. Like maybe we think, you know, if we had birth locations, we could sample them or make them up. But if we had birth locations closer than county, we could figure out where the distance to the nearest hospital was an important covariate for our model and consider that in the DAG. And you generate that, stick it alongside your variables, and run the model. So you know, the spatial analysis really puts new tools in your modeling toolbox also in a really great way. And we'll do that on Wednesday, including talking about some sort of my most current map projects that I'm working on, because I think they all sort of they're all very understandable, and you'll have the tools to do any of them at the end of the week. Okay, but first we'll have probably like a dozen slides and just why are we doing maps again? What's the point? So they make communication much easier. Again, we talked about the improved model idea. You know, just 1 or 2 map savvy, distance savvy covariates can really help when you're making sense of your model, trying to fit a model. And then linking data, it's great. So being able to say, well, their closest hospital is whatever, so let me take the attributes of that hospital and merge them into a birth record. Or you know, spatial merging is the thing that I'm increasingly doing. It's really helpful to say, well, you know, what's the nearest such and such, and what can we benefit? How can we benefit from that data with another first data set? So big picture, there's 4 general types of GIS data, right? So there's going to be points. I think this might be oil rigs in Texas or something. You have line data. So in this case, I see probably what would be 4 lines. Well, then there's the underlying river file, but maybe this is a road or some elevation line. And the lines are going to be constructed of ordered points. This is like, what is geometry? But thinking back to like what the structures look like under the R hood is going to be useful. Like if you want to merge 2 lines, R has some great tools for that, but remembering that what that's about is really figuring out whether the lines intersect, which is taking the 2 lines and 2 lines and figuring out if they cross. And thinking through that spatial math is helpful. So lines are made of points, polygons are made of lines. I'll also flag here while we're talking about polygons, we won't go into this, but there's some useful, if you're doing polygon work, things to note that can happen. For instance, a polygon could be poorly closed. You might have a data set that's got an error somehow, and you've got a polygon that looks like this, and never ended up closing itself. And there's ways that R can, in a single line of code, find the fact that these are the nearest, or find this intersection, or drop out errors. The polygon also might have a hole in the polygon, which is then useful to know what that looks like in R when we get into it. You won't have to do almost any of this work. 99% of the time, R is just going to handle questions like, is that line over that polygon? Yes, which makes the R abstraction really, really great. But every once in a while, you'll have a data set that's got some oddities to it, so keeping track of what these things are underneath is useful. So lastly, I do some, but not as much data with rasters. You can do a raster as basically a cell tessellated plane. So this is looks like plots, or maybe even like a satellite image, or kind of dummy satellite image. But you could then ask questions of that satellite image, like, well, if we're looking at it with a certain band, where we can then distinguish what is water and what is land, then any cells that look like this, or I'm going to call land, any cells that look like that. So being able to take a picture, sometimes literally a picture in the case of a satellite, or even like identifying whether something is an orange or not, is a classic machine learning question that looks really similar as a question to sort of these spatial questions, right? They're raster type questions, or questions about a tessellated image of data. We won't do much with rasters today. I'll demo maybe 1 or 2 projects with it. But most of the work that I think is easiest to do is done on spatial polygon objects, so points, lines, blobs. So quick show of hands, who's used ArcGIS before? Probably most people. Yeah, not everybody, but it's real popular. It's popular the way SAS is popular because of lobbying leverage and other things. But it's also been around a long time. And then, like SAS, it's been around since like the 80s, maybe. We're not going to be using it, but it's important to understand it because the most common GIS data format is a shape file. There's a little asterisk there because it's really files, sort of all sitting next to each other. And it's a legacy file format that we've now, sort of the rest of the world has really moved on from. So like if you're looking at a map that the New York Times built, it is not built on a shapefile. It's built on a GeoJSON file, basically a JavaScript description of the data. It's a little more efficient in some ways. And there's a bunch of other formats too, including a format that we'll look at in R, where R can mirror this very traditional older format, what we call an SP format for the shapefile, spatial polygons object, or a simple features object, which is what we're going to try to move to as much as we can. It's basically a tabular version of a shapefile. It's going to have all the geometry data in a column, and then all the attribute data in the other columns. So like, birth so-and-so, here's the date of birth, here's the name, whatever, and then one column will have the lat long data for that point stuck in that one cell. And that sort of rectangular data allows us to do really cool stuff like dplyr work and group by whatever and all that stuff. So, so that said, though, we're going to spend some time talking about the shapefile format. It's a great intro to how R stores / used to store the old version of the way to do this work in R. And it's got an equivalent. So QGIS, which I mentioned before, is a free open source like R, constantly in development, does a lot of cool stuff, has cool packages. I think they're called plugins in the case of QGIS, but basically the same as our libraries. And yeah, so you can download QGIS if you want. I do a lot of work in QGIS now just because it's always available and it's with a license, and you can open a shape. You can do anything you can do in R. So it's great. Okay, so on to shapefiles. So again, it's the most common GIS format. It's going to have a bunch of different files. Here's the sort of 5 most important ones. There might even be a 6 or 7 occasionally if you compress it. But there's a geometry feature information file. So like if we saved out a spatial version of our birth data where every birth was attached to a point, let's say. Every birth now has a lat long associated with it. So it's a spatial points file. That SHP is going to have all those coordinates with an index for them all. Here's where a person record 1 is. Here's where record 2 is. Then sort of I'm going to skip to the third. The next most important one for just thinking through this is the DBF, which is really just a comma-separated file. It might be tab or comma, I forget. But Excel can just open them natively if you associate Excel with a DBF file. It's a tabular file that says, okay, well, in the shape file, you're going to hold on to the point data or the complex line or polygon data for that record. But in the DBF file, we have the tabular row of data that's associated with that. And you've got some other pieces that I almost never fool with the SHP XML meta documentation. I'll do a lot of that. And then the SHX is almost always generated. You don't have to mess with that very much. The projection information is important. We'll cover projections very briefly. But in short, it's not a flat world, and we're going to put stuff flat on a map. And so figuring out where exactly you're centering your sort of window onto the world, and then what way you're going to flatten that curvy surface is the projection. And there are a lot of common projections. The most we're going to work with them in R later today. Lat long is a really, really common one, just world WGS 84 world reference. It stands for exactly, but WGS, I forget. But the WGS 84 you see a lot, and that's just our traditional lat long system. That's not really a projected system onto a flat surface. And then the other projected that was common to work with here in North Carolina is the North Carolina State Plane projection, which describes everything in X and Y's on the feet axis. So that way, if you say, what's the distance between A and B? The answer is in feet. And it's taking that curvy surface of North Carolina, centering it within the window and stretching it out to be at least in the center of the North Carolina especially, but it's not horrible on the sides. Be able to ask those sort of geometric questions on an X and Y plane in a way that then makes sense. If I ask for the distance between something in an unprojected lat long, it's going to give me the distance in degrees, and what that really means is sort of tough to interpret. So very, very commonly, you'll have to mess with your projection. It's a one line of R code, or it's easy to do in QGIS or ArcGIS to reproject something that you got in one projection to another projection, so that multiple layers can line up on top of each other. So the projection part is really important. We're not going to cover very much, just enough to know how to reproject. But you could spend a while on is this projection better than that projection? There's videos on this. It's in pop culture now. Those are projections. But yeah, I mean, imagine if a Word document was split into 5 files. It'd be a little annoying to work with. And so this is not like the file format of the future, and it's kind of annoying to work with. Most typically pass things around as a zip file. You should have, in fact, if you downloaded the map file or the map data pack, you should have a North Carolina counties shape file somewhere buried in that data pack. I think it's in the maps directory or something. But if you haven't seen one of these files before, that's what that looks like. So we covered most of this. So the SHP is the geometry feature. So in the case of points, it's a list of coordinates. If it's polygons, it's also a list of coordinates, just in order and then attached to each other. And the software does the work to say, oh, for X from 1, 2, 3, 4 is all going to be attached. We don't have to fool with that stuff. So I cover most of this. So yeah, lat long, GPS, lat long, pseudospherical, projected. Again, like feet or meters, or some sort of rectangular projection is what I'm most typically going to be working with. Those images I think are useful sort of visuals for me. That cone one in particular, of like I look down with a cone and then I say that was flat, or if I cut the space with a flat. So it gives you a sense of different ways that you could cut a curvy surface into a flat one. Which will also mean that there are some areas that if you're in a certain projection, if we're using the North Carolina State Plane projection and trying to interpret things out in Seattle, it's not going to be very good because the projection is going to get worse and worse the farther you get from that center point, right? So, yeah, so you'll typically have like a local projection that you might be working with for these kinds of distance questions. So DBF, again, is just a table. In fact, we might open up one in just a second. It's just a regular data set, which means that we could merge stuff into this regular data set, which is what we're going to be doing. So thinking about the approach of like, where is my tabular data in this object, and how do I get my results into it alongside it? so that I can then plot it in a regular way. And there's a bunch of other stuff. This doesn't matter that much. You can't delete it, but you won't have to fool with it. So QGIS is, again, like ArcGIS, the place that we're going to be doing most of the, I would say, cleanup. You know, like for more complex labeling or really pretty legends, you know, R is getting there to just out of the box make a really nice map that you can print out. More typically, I'm using it for very fast exploration of my map data. Or, you know, I've made a map of you know, our birth stuff. So we're going to make a map of our birth results by county. For instance, we had that table that we made a graph of before. And let's say I wanted to get a sense of whether there's spatial autocorrelation clustering of low preterm birth and high preterm birth areas. I'll make a choropleth or, you know, colored polygon, which we're going to do today. You know, that kind of question in R, especially with a county, you know, but even different lower level, more detailed geographies, is like 3 lines of code. So if you're getting sort of familiar with this, you can be running a model that has something to do with geography, and say, you know, I wonder what that looks like on a map. And like in 3 lines of R, you can take a quick look, and that just having that it being so facile that way to be able to easily see whether something else is going on that you have to consider is really what I'm using R for mostly. Then, of course, the spatial analysis stuff that I don't want to have to click through every time in Arc or develop some long chain of commands in their command chainer thing. Just press run again, and it'll take the stuff I did before, redo all the spatial analysis, and I've got my shapefiles back out. So I want to take a moment now to pop open QGIS and to show you how easy it is to start doodling around here. You know, the nice thing about a GUI, about a graphical user interface, unlike R, which is actually developing one, but largely not a graphical user interface, is that you can like pan the map around really easily, and you can you know, click and pick the color on the color wheel that you want, and that stuff is nice. Here. Education. I'm going to go hunt for my county shapefile that we're going to start this classwork with. Let's see from the data. I think it's in maps. Okay, cool. Okay, so I opened QGIS. So I have a bunch of recent projects that I'm currently working on for papers and stuff, but I'm just going to say make a new project. Oh, I have this. QGIS is saying, hey, there's a new version of QGIS variable. I typically use like the most fresh version, but you don't have to. But they're free, so I'm like, oh, there's a new version this month. I'll go ahead and download it. Just a nice little update. But let's see, I'm going to make a new one. I've got a big blank canvas. I've got these shapefile thingies. So this would be just as if you downloaded it from Census, or NC1Map has a lot of great layers. We'll use one from later today. So let's see. So I got NC counties. I'm going to drag it over here to layers. Hey, I got a map. That's it. So it's a map of nothing right now, but maybe I want to change it to, let's see, I double clicked on it. So I'm going to say I want to make a graduated map of, what have I got in here? Nothing good. Okay, here we go. Yeah. So this, I don't have any data in this yet. This is just exactly as I get it from the census. But maybe I want to do like area of land. Looks like it read it in a dummy way as a string, but this will still give you the idea. And make a gorgeous map of nonsense. So there might be some note in one of these fields, and that sort of work that you can do in R really easily to clean up and say, oh, you know, you needed to make this whole column as numeric so that QGIS can better understand what's happening here. So yeah, we've got area of land here. And I could add more layers. Actually, the only other layer that I have quickly available here is what we're going to generate today, which is a similar file but has our attributes attached to it. So, like in this one, I've got PNC and preterm and a bunch of other stuff. What's happening here? There we go. Let's change the symbology on this one to graduated, preterm, and I click classify into 5 different classes. Weird looking map. So it looks like maybe one of them has a, maybe this is the number of preterm births. Yeah, it's the number of preterm births. That's not helpful. Let's do this one. There we go. So I'm just clicking around. I mean, like if you use ARC before, it's no different, you know. But if we can generate a file that looks like this in R, that's got the data attached to the shapes, then if I want to, I can save this project and add a bunch of other layers. Then just like the Excel workflow, if I rerun my R and change that reference file underneath QGIS, all of a sudden the maps are all updated in QGIS. And so you can have all your layouts and nice printing and stuff happen in QGIS or ArcGIS, doesn't matter. And yeah, then just rerun the analysis, change those files, open this up again, and you're done again. So having this be sort of the end, holding on to the formats and the end product, and then you change the data underneath it, and that model works really well in R. So we won't come back to QGIS, but that's as easy as it is to poke around. Okay. Back to here. Okay, so we just did this. So yeah, and if I had maybe like roads, I could drag the roads in, change the symbology of those things, and yeah, it's just pretty much drag and drop. It's really straightforward. There's also great documentation of it too.
Can you install the OSGeo or standalone?
It doesn't really matter. Standalone's fine. Yeah, they're all like, we're not going to be doing using a lot of the QGIS command line stuff. So it also installs these sort of background things. I do typically install like the Alaska and North Carolina data sets just to poke around, but if you've done this a couple times, you don't have to do that. It's going to ask you like, hey, do you want these dummy data sets? Doesn't matter. Okay, so yeah, so thinking about this, I'll pop back over the shape file, right? So you can see I've got North Carolina County's DBF, PRJ, our projection file, the SHP, and this SHX file that we were not going to use. So that corresponds really closely to this first package we're going to introduce that handles spatial objects in R called SP. And it's going to have, this is a new syntax for us because we haven't used complex objects before, but you can think of them just like a list. This is a little bit bigger. So we're going to have a single entity called a spatial points data frame, and maybe we call that counties or whatever. And then it's going to have a bunch of slots. And these slots are just similar to our list elements, right? So we would reference them with a $, name of a thing, $, name of a thing. This is a little bit more flexible in that these aren't lists. They can have more complex structures than that. But think of it like a list. So we're going to reference it with like counties at polygons. That's going to give us all the polygons, basically referencing that single file. Or counties at data is going to give us a data frame of all those attributes. Counties at projection string, bounding box, plot order, a bunch of stuff we don't typically do a lot with directly. You know, we'll have a function that changes that projection string, that proj4 string. And then you can also, again, use that bracket notation to subset, which is real slick. So, so we'll see this when we get into the code. But imagine now I have counties is a map. But if I wanted a map of just the counties where its name is orange, you can see how it looks just like what you've seen. Like, you know, that syntax is just treating it like a data frame. I just want the rows of this map, or rows of this thing, where it's orange, or where the percent preterm is greater than 5, or the whatever. I'm referencing the rows that way. And if I plot that, a map of Orange County comes out. So this is where like the tools you've already used start to be real useful when you start to see other types of objects that really are going to all act the same way. We're going to, again, this is the overloading functions idea in R. We want to have you learn one set of functions that are going to kind of quietly under the hood work differently, but be the same syntax for you. So yeah, or I could put in the columns area, I could say I want the map, same map object as before, but just keep these columns. And a list of columns could go in there, or just columns whose name begin with whatever, or any of those kinds of questions. So yeah, a couple more, just 1 or 2 more slides about this before we jump into R and do this. So RGeos and RGDAO are both packages. So under this old or foundational framework, you very typically say library SP, library RGeos, library RGDAO, and that'll hold on to the spatial. The SP has the objects themselves. RGeos and RGDAO allow you to ask questions like buffer and central and some of the spatial analysis tools. But yeah, we're going to be saying just like you can plot a thing in R, we're going to say plot that map, and a map comes out in the map buffer or the plot area. Or I can reference it with $. When you're using a map, the $sign is going to automatically know to go to the data part. So it's really the same thing as saying map my shape at data $1. Reference it the same way, or some individual reference there. And I can steal stuff out, right? So I can say gbuffer this 3 miles, 3 times 52, 80 feet. If this is the feet projection that this is in. And gbuffer will make my circles around that object, and I can save those circles under a 3-mile buffer object. I want to then save that out to then have as a new layer on my QGIS. It's just a write statement. It looks just like write CSV that you've used, slight tweaks, but I can write that out or plot this on top of that. So we're going to be doing the syntax of working with this is going to look just the same, really, to the way we've handled objects in R already. So I'm trying to move away. We're trying for about a year or two since the folks introduced this, who are the main developers of these spatial packages, moving away from this SP universe of libraries, and this structure, the structure here. Where you've got an object and then slots, and then it's kind of like this complicated list, right? It's like it'll look like the models we ran, right? And those models are not tidy. There are lists of nested lists of things, of all these things, and you have to reference the function. So that's the old way of doing it that we're going to start with today. But more typically, at this point, I'm using SF instead of SP. So that's called, that stands for simple features. And this simple features is a spec or agreed upon file format that then had a bunch of discussions on, well, should this happen, or how should it operate like this? And I got a bunch of consensus opinions on it and designed this new. This isn't even specific to R. Designed this structure for spatial data that's more easy to work with and more robust for asking complicated questions, and it's faster in many ways, not always, but many ways. Called simple features. And again, this is exactly a data frame. Like the way that we introduced Tibbles before, where a Tibble is really a data frame. It's like a tidyverse version that prints a little bit smarter and can maintain information about groupings, part of the dplyr lecture on Tibbles. So you can say, this object is a data frame, but also a Tibble. SFs are simple features objects and data frames, and technically, I think Tibbles. But they're going to store in a rectangular way. We'll have all of our attributes just like we expect to have them. And there's going to be another column, a list column. And in that is a geometry string that describes that particular object. that subset, that record of the row of the object. And the next one has theirs, the next one has theirs. So that way we can ask questions like we will today, like take all the counties, group them by the county tier, summarize them by the number of births, plot. And it will automatically spatially join when it does that group. Join all the tiers together and then give you the map of those things. So being able to ask dplyr questions on spatial objects is one of the benefits of having tidy map data. That doesn't quite click yet. Again, we're going to run some code. But I just want to flag that we're going to sort of balance between two different, what's the word here? It's sort of like universe, but two different whole systems of how to handle spatial data in R. And you can translate back and forth from an SP class to an SF class. There's like a simple function to flip them back and forth. But you're pretty much using one ecosystem. So you're using like one ecosystem of functions. You're either using gcentroid for an SP object or st_centroid for the SF object. And typically you'll sort of pick one and go with it. And my suggestion will be, even though I'm introducing SF, if you're going to do this, start learning SF now, because it's mature enough to just make the switch over. This was last year I introduced it as like, this is happening and probably pretty important, but maybe don't switch yet. But now it's like, this is the way we're doing it. Just do this. Okay. And that way you also remember, if you know about SP, you can then keep track of how great SF is. Because there's things that are real annoying to do in SP that are just snap your finger in SF. Okay, can't read that. So I think you have the code for this. You'll need to probably install a number of new libraries if you haven't run them already, because we now have 5 or 6 different libraries up here that I'll talk about what they all are doing. Because I'm going to demo a bunch of different ways to plot and the whole, 2 different ecosystems. So on a typical project, I won't need, half these libraries. It's like tidyverse, SF, really. But the rest of the stuff is sort of for more custom printing and some other pieces. Okay, let's get ourselves some font size. Okay. Okay, so I think this is going to work. Let's see. So I'm going to Control-Shift F10, give myself a fresh environment, back up here and load that map data file. So I am going to separately read in, to show you how to read in these objects. I think I'm going to have a write, or can quickly write a write statement. But we're going to start with just having these 4 objects in place, just to examine them first. So county results looks like this. You recognize it. We built this many weeks ago. It's got the co-res, the county name. I believe you should have FIPS code. If not, you've got it when you load this file. But I tried to leave the FIPS in that original merged in data file. There's a column for FIPS and the helper column or something like that. But FIPS is the U.S. actually. It's worldwide. A U.S. numerical representation of different spatial areas. So 37 is North Carolina. I think U.S. is like 1000, then there's a buffer 0, then you get the state, then three numbers for the county. If you went to the tract, it'd be 4 or whatever. So this thing gets longer and longer, but is a unique identifier for any spatial area, like zip code and different tips. Zip codes don't really line up very well, but we're going to be merging on county name because we've got these exact, but this happens like every week in my work. Someone will send me something to make a map of, or I want to make my own map, and someone's county list has a typo in it, like every single time. Or like, is that St. Helens with a dot, or St. Helens with ST, but no dot, or or a space in New Hanover, or New Hanover. So it's useful to know about. Mark, I spent a lot of time on it, but when you download your data, aim to be merging on something more numeric than name if you can. Here, I would make sure that this matches the data we've got elsewhere, so the names are going to match up. And then we've got stuff we generated, right? So the number of This is number of births, number of preterm births, PNC5, again, count, then PNC5%, and or percent, percent PNC5, and then percent. Scale 0 to 100 just to make the maps a little bit prettier rather than have the 0 point whatever. But this is a data frame, right? We've seen it before. We could cast it to a Tibble. It's going to be the same. We'll look at now the NC counties. Let's see if I want to do this with. I want to do this now. Yeah, let's hold off. So we're gonna look at those spatial objects in just a second. I want to do a quick, just show you. You've got this code now, but a quick demo of what you can do in R around spatial objects. We're not going to run this code actually because I don't need to. I've already downloaded this, but this little block of code, it's I don't know, 10 lines or something. Checks to see if I've already got the map file I need. I'm going to read it in a second, and if I didn't, I'm going to make sure that that directory exists. I'm going to run the download file command and go to the census FTP site and go pick up the most recent county, unzip it, give myself the what's in that directory. Actually, I can't remember what list files or I forget what this does. If I wrote this and I forgot, I should put a comment. Then I read it. So the thing is, the census doesn't always give you like electronic counties. So here's the U.S. county file figured out. So I read in the U.S. county file, then or download the U.S. county file and read it in using I'm reading in the SP ecosystem. So read OGR. Now because this file is like we're treating this file like it's 5 different files, I have to say the destination is maps and the layer is this, but I really want you to read in all the things .shp, .shx, dbf, whatever. So the syntax looks a little bit different than your typical read CSV statement. We're reading one file. This has been fixed in SF to just say, if I point you to an SHP file, assume there's a bunch of other helper files and you just read that in, please. This kind of syntax is a little annoying, the directory and then the layer name. But then I plotted it. Then I've subset it. So the U.S. counties is a map. U.S. counties, state, BIPs, it's 37. Gives me all the North Carolina counties, and then I write that back out. So I could run this one time per project, or save it, or just go click through the FTP file and download it. If I just wanted to demo how R can do some pretty slick stuff, if you have to, for instance, regularly update a shapefile, you could go download the file, check its vintage, when was it last updated, subset it, and then start your project with a little if statement. Okay, so this is me actually, need some libraries, huh? I'm not going to do that without libraries. On my libraries. Okay, so we're going to spend some time in the SP ecosystem first. So, am I in the wrong directory? What's going on? Yeah, it's not right. Does remind anyone what Nick said about projects last week? Yeah.
I had project open for another project. Then when I opened it opened in that project.
Yeah.
Yep.
Yeah, you have to close your previous project. You weren't done with it, you said, right? Yeah. No, I know. I think so. That's what I've been doing. Sarah, what do you think about that? Is that what you have to do? If you want to open a file but not have it open within a project, I think you can do it.
Well, now I just changed my working directory.
Yeah.
So like after that, I have to go back. Yeah, but it also seems to the benefit of having a project.
Yeah, that's a good question. I mean, I think that's
Can't read the tab.
just
having a separate project for like each distinct thing you do. So like what you're referring to, I'm actually doing, like I'm in my, like this morning I've been working in like the project related to my dissertation. And
Me
this
too.
class, I'm just opening R scripts in that and running it, which like isn't the most efficient thing, but I think it's exactly what you're running. Like really, I should be owning a project for this class, which I efficiently do not have.
I also don't do.
So I will fix that now.
Yeah. I'm not gonna fix it. I think you can. I don't think you have to close the project. I think you do need a new session though, and I don't know where that button is. But Pastor Nick, I don't know. I typically close down my whole other project and then open a new one. Was there a question?
In that same Dropbox, you drop down right that I showed last week. Like if you click on that arrow, you can say close.
Yeah. This is the closed project, which then gives you back all of the free floating scripts. But I don't know. But I think your question is also like, do I have to do that? Because I would rather keep my dissertation open in a different window.
I just keep all of them.
So we don't know. We collectively don't know. Nick, our project master, please come back. Okay. So sorry, it took me a little bit. It's hard to navigate when your font's this big. My screen's very tiny. So I got my directory in the right place so that I can then say read ogr./maps. You could also just give it the exact absolute location. And then I asked for the layer and see counties, which I just made myself, and then strings as factors as false, as usual. I don't want to read those in as factors. It's the same thing as if I'm doing read.csv. Okay, so I read it in, and you can see down here, I've got, hey, it's saying it's an OGR data source with the driver. It's going to use the Esri shapefile. It's node to Esri shapefile. You can read a bunch of formats here, but typically we're working with shapefiles. I'm working with shapefiles. And what else we got? It's got 100 features. So 100, think about 100 rows. These are counties. And 17 fields, 17 rows, or sorry, columns of stuff. So now we can start investigating this weird object we just read into R. So what's the class? It's a spatial polygons data frame from the SP package. So if I had read this in, if I had read a bunch of points in, it would say this is a spatial points data frame versus just spatial points, which you could also have. You know, there's no associated data. These are just geometries, but I don't know anything about them. There's points, just polygons. This is spatial polygons plus an associated data frame, so an SPDF, a spatial polygons data frame. But now that it's in R, you know, that's one line to read it in, and I can say plot. There it is. So we're getting there. I mean, just that was like wild for me because just, you know, being able to not have to open potentially like memory hog of a piece of software next to R, right? So I don't have to open QGIS or ArcGIS that are pretty big pieces of software. I can just like quickly read in this thing that I maybe just made or found, and then quick look at it is already pretty slick. So we'll, just like we did when we ran the models, let's take a look at this underlying structure here. So this is a formal class spatial polygon data frame. You've seen this before, you know, class, data frame, class, whatever. But it's got 5 slots. Again, this is our new bit of syntax that we will only really use today and probably won't use ever again. Underneath the hood of this spatial polygon data frame is a data slot. That's a data frame. And a polygon slot, which is a list of 100 things. List of 100 polygons. The plot order is basically random, but it's important because polygons don't necessarily have to abut, right? So they could be on top of each other in some funny way. Imagine if I took a bunch of points and asked for the buffers of all of them and just saved all the buffers. Some of those buffers might overlap. And so I may want to clarify what the plot order is. Maybe it's the most recent buffer goes on top. And typically I'm not fluent with this, but I'm just knowing that they don't have to always be side by side. And then a bounding box. This starts to get really important. Again, you probably won't have to do anything with this unless you're getting spatial analysis, but it really helps the efficiency of spatial analysis. So for instance, if I want to know whether or not this complicated object is over this complicated object, That's potentially a very difficult mathematical question, unless I go, hey, by the way, no. You know, if you can collapse that down to a bounding box question, you can really speed up your spatial math. You know, if the two maximum distances don't overlap, then it doesn't overlap, and that can be really useful for more complex spatial questions. And then this projection force string, which we'll do a little bit with later. That's telling me that this is currently right now in U.S. feet. You know, North Carolina state plane U.S. feet. I think is what it is. But we'll take a look at a couple lines of code. So that is what when I say max level is 2, that's the high level, right? If I ask for the whole thing, it's like, oh yeah, I'd be happy to tell you what that object is, right? So this is just like really unpleasant. Just like the model object is like too big to ask for the structure for. It's just a mess. It's like there's too much here. It's complaining because I shrunk the plot down to too small of an area. Like it's like I can't plot the map if you give me a centimeter. So it's whining. There's also, we're not going to review it, but a package called Tigris, which works with Census Tiger files, and an ACS package where you can just directly ask, like an online question, hey, could you go give me the North Carolina counties? And it will pull down the counties and you can save them, rather than writing this code I did it myself at the top. Or I'd like the population for Wisconsin in 2000. Give me the data for that. That's what ACS is for. So there's a lot of cool packages written around APIs. You know, the census has an API where if you ask it the right question in the right format, it can send you stuff back. So these packages provide wrappers for those APIs, so you don't have to like write that code yourself. You can just say, give me, you know, tracks for North Carolina. Okay, so I want to jump right into like how would you really do this? Right, we've really only run maybe 2 lines of code. We read in a shapefile that we got from the census, or I made, but same thing as what you get from the census. I took a quick look at it, just like I would do head on a data frame or, you know, plot. Just, oh, okay, it looks good. But now I can merge. I've got these county results, right? If you remember, county results table. They're beautiful. This would be nice if it were a tibble. I think this works. Let's try it. Tibble. Okay, so there's our county results, and I've got a FIPS in there, and oh, I should take a look at the head of our. So this map file head is going to default to giving me kind of a mess of stuff, telling me the names there. But what I really care about is the head of the @ and I typed @ and waited, and it popped up the data frame, polygons, plot order, bounding box. I want the data, the head of the data, which is just a data frame. And again, we're into printing a data frame, which is not always pretty, but you can see these are the values I've got as attributes for all of my county polygons. So name looks good. I could probably merge on name. I've also got that nice GeoID that's guaranteed to be exact with no typos. Sometimes it needs a little bit of massaging if there's like a buffer in the 0 between the tract and the county, but we're not going to get into that stuff. Then a long name. This is the way the census keeps track of its polygons. This is like really, really the same for every, if you ask about this, you know, data from a tract or from the state or from a block group, it's going to have the area of land, area of water, the interpolated lat and long centroids, basically, so that you can reference them that way. But this is very typical of what comes just out of the census as attributes. Nothing useful for us. You know, we're not interested in the area of land or water. But then we got a statement merge. Merge NC counties. Note, having made this mistake over the course of a very long project many times, I'll never make this mistake again. Note that NC counties is the polygon object. So you might want to, because I did, say NC counties @ data, and then say NC counties @ data equals, where I'm directly referencing the data frame part of my spatial polygons, and I'm going to merge some data. It's going to overwrite that slot. But when you merge something, for efficiency's sake, you're not guaranteed to know what order the thing comes back in. So if I don't let R know, hey, these NC Counties.data and NC Counties.data just says data frame merge on top of data frame. And it will do, I erased some stuff. Okay. Ignore this column. Let's say I've got A, B, C, D, and A, B, C, 1, 2, 3, and so on. I might get back A, C, D, because it might go down and say, I'm going to merge this one and then walk down to the next one and then keep looking from the bottom, or whatever's most efficient, whatever's the fastest way to merge, it's going to merge. And so you'll get a different, you'll shuffle the attributes basically behind the scenes without intending to. So SF skips all these problems, but here, if you ever use SP, you want to be making sure this is your spatial object in the front and this is the spatial object I'm overwriting. And because it's spatial, it's going to know, I need to keep these things in the order because they're alongside a bunch of other data like the polygons that I'm not touching right now. Even if you reorder them, make sure you get it back in the same order. So there's a lot of explanation for what's a simple line of code, though. NC Counties is merge that data on, and then we're done. You can see I've got now those fields at the end of my attribute data. And SPplot is a, yeah, you can squeeze it in there, come on. Is a sort of out-of-the-box quick graphical plot that is in the SP package. So if you use plot, this is like the equivalent of base plotting in R. Or yeah, you can say plot X and Y, and then go through and change the colors by hand and sort of fight with the base R plotting. But I don't typically do that very much. It's base R is very fast for quick plots of spatial objects. But if you want to add colors and legends and stuff, it starts to get a little annoying to work with. So SPplot, again, in the SPplot package, just takes a plot and a column that you want to make the color. You can give a title and some other stuff you want, but I just gave it a title. And it's not pretty, but it's a quarter plot. And it's a quarter plot of our real data, and that was really 3 lines of code, right? So I read an accounting file, I merged in the data that I had, and I plotted it. And like, that's all you have to do for homework 5, by the way. Like, if you've looked at homework 5 math question, 3 lines of code. It's just make a plot any way you can of something that we need. You know, make a county plot. And it takes no more than 3 lines. Now, we're going to do a lot more than this, but I just want to say that, you know, if you can read those 3 lines of code, you can make maps in R, and you can, you know, run data or models or whatever you want, and then make a core plot and see what you think about that data. If you then write that data back out, you can then futz with it in ArcGIS or QGIS or whatever. So, oops. So if I write OGR, I hate the syntax. Let's see if I get it right. The destination. So it looks just like the read syntax. Like this. I'm going to give it a location. NC Counties results. I want the name to be the name of the file. This will eventually clean up. Here's the thing I'm trying to print or trying to write, similar to the write CSV syntax. I'm going to give it a directory. I'm going to give it a layer name. I have to tell it what driver it is. I want you to write an Esri shapefile, not a GeoJSON file, not a whatever. Did you get it? Yes. Esri shapefiles also don't allow you to have more than 8 characters for a column, so it's going to kind of quietly try to shorten the name of your the names of your attributes, which is a little annoying. I'll pop over to here. Let's see, where am I at? Oop. Maps. Yeah, okay. So here's the thing I just wrote. Again, there's the write statement is there on the left, and then I wrote to a directory, told the name of a layer, and that I wanted a shapefile out of it. And I could drag. This is the same thing as NC Counties with data that I had already pre-done over here. So I could drag this into QGIS, change these garish colors to something prettier, and make a nice layout for it. So, that we're going to do more today, but that 3-line workflow is all you need. And, everything else is sort of bonus, but I feel like you could get a lot of mileage out of just those, read a thing, merge some results that you made, spit it back out, plot it maybe, and spit it back out. Okay, so moving on though to some slightly more advanced stuff, or if you've made some maps in R and you want to get a sense of some other ways to do this, we'll make an SP plot of the other one. So percent preterm, and it's also got some funny distributions here. This is percent preterm, looks like from 0 to 20%, but 20% preterm bursts is kind of a lot. They don't seem to cluster, though. Maybe those yellows are a little bit farther out from the Piedmont area, the central area. Take a look at this one again. This one here, the early PNC. Just kind of get a sense of the clustering. You can do it. Where are you at? There it is. Yeah, maybe. This area might be lighter, which is an early PNC, early payout here, maybe. Also, maybe fewer births. So, having a couple of maps at the same time would be useful. If you do have multiple columns, this is the SP plot now library of SP plot family of plotting functions. You could also plot two things at the same time. So I could say SP plot counties, and I'm going to give it 2 column names here at the same time. Percent PNC5 and percent preterm. These aren't exactly on the same scale, so the map isn't very good. But it's now different. I could say scale 3 and have them be on separate scales if I wanted to. But if I had a couple things I wanted to plot at the same time, this is now a consistent scale for percent preterm and percent PNC5. So you can eyeball a couple plots at the same time with your data and get a sense of whether or not these two things are collinear, like spatially, basically. We could also run a correlation on it, and it would give you something similar. But okay, so you can ask questions of our data, right? So these two things are going to be the same. Again, I said that the at data is the default when I use the $ list operator on a spatial object, on an SP object. It's assuming, hey, you probably mean the data frame part. So I could ask for the sum of all of the births in all the different counties. And I could also say, give me the sum of all the counties where the counties are in orange, Durham, and Chatham. This is exactly the same way that you would ask it of a data frame, right? So we could touch up, do a little bit of customization of that plot. So I could maybe make a new variable, PNC early, or percent early PNC as a factor, and use cut, right? So the cut function gives us a factor that's leveled out for us. In this case, it's going to give 7 different cuts by, I think, basically like percentiles. And I can print this, and using the Brewer PAL from the R Color Brewer package, I think we actually pop this up at some other point. The Color Brewer 2. Right, so just thinking about what colors we might like. These colors are all part of an R Color Brewer package, and so I just cited the red, yellow, green, which I think is this one. Yeah, so three class red, yellow, green, and I asked for 7. So this is exactly what I just got in R by using the syntax. Color regions are going to be give me those 7 colors from the red, yellow, green palette. This returns to me a bunch of hex codes that specifically reference those colors. You can do something similar with base plotting. I don't do this very much, but my most typical use of base plotting is when I've got 2 or 3 layers and I want to just quickly see where they are on top of each other. So I would say, plot 1, plot the first thing, and then on the second plot, I'd say plot second thing, comma, add equals true, and it'll slap those points on top of my polygons or whatever. We'll do that in just a sec. So I don't use it very much, but take a look at maybe all the colors from Art Color Brewer. Okay, those are pretty. I'll pick one of those. I'll assign those colors, cut them into 10, 10 red, yellow, greens. Now I'm going to just plot this, which is going to use the base plot, and say, for the color, I want you to use these exact colors that I just described. Maybe give it a title. So that's not bad. I mean, if you want to kind of get in there into the guts and make yourself a column of colors for each of the plots, you can also then, I'm using Gcentroid. So see how, and we just did some spatial math in the line of code. So that's Gcentroid on the counties by ID. That gives me now an object. Just do this. Plot this. Look what we got. Centroids to the counties. I'm going to run that first plot again. And now when I run the text function, text automatically does add equals true for base plotting. Can't see much that one, super tiny, but yeah, I have to maybe increase my font. But on my screen, I can see that these are really tiny names of the counties. I'm on the fence. I think I'm just going to show you this next version because it's so out of date and annoying. This is how we used to have to get SP objects into ggplot. Like if I wanted to do layers or if I wanted to use the ggplot syntax, the old way of doing this was to use from the Broom package, use a function called fortify, which would take the parts of the polygons and make it a tidy data frame. So I'll show you what a mess this is. I want to dig into this. It's not really even worth getting into this whole thing. So it's a not human readable, but it's tidy. It's long. So ggplot knows what to do. It's going to say these are all the points of Alamance County. Alamance County's got a tiny little piece of a plot looks like this, another tiny little piece of a plot over here, another, it's giving it like coordinate by coordinate chunks. And then so the ggplot knows to then go through how to colorize each of those little chunks. Then you have to merge the data back into this because where the data go, like this, I just fortified the shapefile, and that's what you get back out when you fortify the shapefile. I've got to merge my data back into it. Don't do this. Just don't do this. I left you this code. You can look at it if you want. It makes an OK map. So I'll run the rest here. And ggplot has nice legends, which is sort of why we used to do this. This ggplot is gorgeous 3 years ago. So then it's got a nice legend out at the bottom. You can also pull the legend long lives or whatever. And generally better colors, color selection. ggplot's a little bit smarter with colors. You've also got all the options for ggplot we've seen before, like you can change the theme. There's a map theme. This is the first one I ran. Is theme, add theme map, and it basically blanks everything out. If I do theme minimal, I now get a lat long. I'm in lat long coordinates right now. Some lat long marks for the counties, which is not nice. Pretty much don't do this. So some other ways, still working with the SP objects, and then we'll finish up on time looking at SF. There's a library called TMAP, Thematic Maps, which has really good documentation. It's much more like ggplot syntax. So this is a SP object, but then I can do things like add a fill, add some borders, add some layout options. It looks like ggplot. Now we have to go to just use SF and use straight up ggplot way more simply. But TMAP has some benefits if you want to make like complicated multiple layers, or it's got built-in sort of map benefits that just want you to know that it exists. If you go digging, you might like it. this is a decent map for not too many lines of code. Again, these lines of code aren't dependent on each other. We really just, we did those 2 lines that we merged the data together into that NC Counties file in line 2 or 3 or whatever. Then you can just run this. So you don't have to run all the different versions of plotting, right? So that's a pretty nice way to make a decent map that, again, you can just copy and paste and drop into an email and say, well, here's a quick map I built of the data we just got. You know, could clean up with more time. Okay, so on to, you've seen SP. You should have some sense at this point of what that data looks like under the hood. From here on, I'm pretty much going to use SF the whole time, just because this is what I'm doing now. It's sort of more current best practice, like I say, and it's also easier to understand. But when you sort of get a sense that under the hood, what SF is doing is hiding the relationship between the polygons and the attributes for you and the projection stuff, and that's all condensed into a single cell of your data frame, right? So this geometry column, one cell is going to have all the polygon information, and by the way, it's state plane projection and also whatever. It's sort of hiding in here, which is usually what we want to do anyway. You know, we don't want to be, I don't have to care about all that stuff every time. I just want to ask high-level questions. So again, this is starting from 0. So we've seen a lot of code, but you could also just start from this. Library SF, we would need the tidyverse up above. Then I'm going to use SF's read function, which looks much more like read CSV. I'm just pointing it to a .shp file, which is one of those files, right? So there's other files I'm not referencing. And it goes, oh, it's SHP. That's an Esri file. I know I need to go look for the rest of the guts of this file. I'll go do that. SF also reads a lot faster than SP, just because of some optimization. I can ask for the structure. The response in the structure should look a lot more like a data frame, because it is. Structure, this spatial object, spatial features object, is class spatial features and a data frame. It's got 100 observations, 18 variables. That's what happens when you ask a question of a data frame like that. Here's the attributes. At the very bottom here, note the last column is a geometry column of spatial features collections, polygons of like 100. The first element is a list of a bunch of 6,494 lat long points that describe Alamance County, vertex by vertex. That's the first element in here. We'll never need to go into it. You can ask questions of the whole object at once, like buffer Alamance County 5 miles. That's it. And it will abstract, to be able to do that stuff for you. But just this is where all the sort of secret sauce is for this SF object. Okay, so all we've done is read it in. If we plot it, the default plot for an SF object is different. It's cool, but typically not what we want. I'm going to do a couple of versions of this. Okay. This is going to take a little bit. What it's doing is, oh, you want to plot that whole object? Cool. I'll walk through every column and make a plot for you. So here's a plot of all the names. No, it's just a plot. It's a plot of colors. Each name gets a different color. Each county GOID gets a different color. Each entity gets a different color. That's not a very useful plot. Maybe this plot looks like it's got something to it, but you could, meaning though that if you want to plot 3 or 4 things at once in SF, if you precisely named those columns, you could do that. More typically, I'd be doing, just plot the first one. So I'm giving it the first column there, and it's the state FIPS, happens to be state FIPS. Or I could say, using now dplyr pipe syntax, which you could use under the SP stuff too, and just say, NC counties, give me the geometry of that. I'll just plot the geometry. Last line of code that we'll end on today, and we'll come back on Wednesday, All the things that happen. Okay. That's a decent plot. But that's literally from 0. So I said, take the spatial object, mutate to make sure that that's that's a numeric column, because for whatever reason it got read in as quoted before. So make that numeric. Left join my tiny results onto it by GOID on fifths. Pipe that to ggplot with a fill on the one variable. My geometry that I want to give it is an SF geometry. It's going to default to looking for the geometry aesthetic. So you could also make it more explicit by fill equals this, geometry equals geometry. That's what it needs to know how to plot the object. Geom SF knows usually you're passing an SF object that has a geometry column and you want them to have some geometry aesthetic. Be minimal on some labels. And there. So we did the merge. We could have read it in. Mutate it a couple times. Left join ggplot, and it's like one slightly long statement, but like from 0 to map in a line. So that's the benefit of having like a dplyr savvy spatial object, is that you can start to ask these questions in language you already know how to do, and then passing it right to ggplot. Okay, that's it. Again, Wednesday we're going to do spatial math, so distance between things and buffers and stuff. But hopefully you've got enough now to finish the last question in the homework. Last homework is done now. And if you have any questions on maps, of course, drop me a line. All right, thanks y'all. Hey.
Do you know what this is? I mean, I used to tidyverse, and now I'm getting this.
That was weird. Do you have string I? What is that? Why is it whining about string I?
String I?
There's no package called string I. So try library string I. I don't know why.
Oops. String I correct.